Exercise 116 is telling you, first it says, the regions that are slightly positive in a compound are the places where that compound is most likely to be attacked by an anion. That's anything that has a negative charge. And so one example of that is hydroxide. You can see that negative charge up there. That's what makes it an anion. And so in this, our goal in organic chemistry is to we want to be able to take any molecule, things we have never seen before, and to know how they'll react with each other. And the real simple principle behind all of it is that negative charges are attracted to positive charges. So if we have something like this hydroxide, which has a full negative charge, if we want to know where it's going to be attracted on this molecule, all we have to do is find out where the positive charges are. Now, you don't see any full positive charges, but you could see partial positive charges. Not written in, but with your sort of X-ray chemistry vision. Look for really electronegative elements: nitrogen, oxygen, fluorine, or chlorine, the elements in the top right of the periodic table. Those are the most electronegative ones. Those attract electrons the most. So for example, we have an oxygen right here. That oxygen is really electronegative, and so attracts these electrons a lot, pulls them to itself. It becomes slightly negative, and the thing bonded to it, the carbon, loses those electrons, and it becomes slightly positive. We have another really electronegative element, chlorine. It pulls the electrons in this bond to itself and becomes slightly negative. The thing it's bonded to loses those electrons, and so it becomes slightly positive. And so now, once you have those partial charges written in, you can see where this hydroxide is going to move in for the kill. It's going to attack either this carbon here, because the negative charge will be attracted. The negative charge will be attracted to this positive charge, or it will attack this carbon here. For the same reason, the negative charge will be attracted to that positive charge. So here we have a couple molecules that you may have never seen before, but we get a sense for how they're going to interact with each other just by being able to identify these partial positive and negative charges. Remember, the other thing you want to always look for these partial charges are metals. Metals have very low electronegativity, so they'll tend to be slightly positive, and whatever they're bonded to will be slightly negative.